Today's lesson is named Elements, Compounds, and Mixtures. We will also recap what's an isotope, an ion, and a molecule as an addition. So if I go full screen, I'll just move my face to the side. So you need to be able to explain the difference between elements, compounds, and mixtures. And for the gold amount, you need to be able to spot an element or a compound from its drawing, particle drawing, or its chemical formula. So I would normally show this with some volunteers and them holding cards, but in today's lesson, obviously, we're not live. So the first thing is that everything is made of tiny particles called atoms. Now, elements contain only one type of atom. So just one type. For example, neon. Oxygen is O2. It's still one type of atom. Even though there's two atoms, it's still an element. So be careful when you define it. You have to say one type of atom. Don't say one atom. It doesn't have to be one atom. So we normally say that elements cannot be split into simpler substances using a chemical reaction. In physics, they might be able to split them, but not in chemistry. Next, a compound. Now, this is important. Some people say different types of atoms. However, it is better, as per the Mark scheme, to say when you have two or more different elements chemically bonded. Note there have to be different elements because oxygen is O2. You still have two elements chemically bonded, but it's still an element. So be careful with that. There has to be different elements. The last one is mixtures. So a mixture can be a mixture of elements, a mixture of compounds, or a mixture of elements and compounds. The key thing about a mixture is that it is not chemically bonded. So I've used the term substances, two or more substances which are not chemically bonded. Let's look at some examples. In here, we have a copper can. Then we have some black charcoal, which is made of carbon. Then we got some balloons made of helium inside, of course. So copper, carbon, and helium. If you look at a particle diagram, this is a solid, so they'll be touching, and looks like this. It's just one color. That's how it's represented. This one's a gas, so the particles are actually far apart. So in the first exercise here, you have to say what each one is. Now, if we go from left to right, the first one has two different colors touching, so it's chemically bonded and they're different elements. So if I'm doing this exercise and I go to the annotating tool, this will be a compound. This will be a compound. This is just one color, so it's an element. This is an element. And this will be an element, this yellow one, because it's just one color. So pretty simple. One more worksheet as a practice. If we look here from the formulae, I2 is an element because it's still one type of atom. If you have a capital and a small letter, then that's still an element because it is in the periodic table. It is called argon. Now, if you have two capital letters that are different, that's a compound because you've got carbon and hydrogen. Here it's a compound, we've got three different elements. Here we have three different elements chemically bonded. Here we just have one element. And here it's a capital letter, which means nitrogen monoxide. So it's compound. Now in the particle diagrams, we use colors to represent different elements. So this will be an element, element, compound, element. I'm skipping this one for now. You'll see in a minute. Now this one contains one compound and a different compound, which makes it a mixture. This one contains one compound and one element, which is a mixture. So they're different elements or compounds, not chemically bonded. And here we have different compounds, not chemically bonded. Now this one, you might say it's a compound because it has different colors touching. But the thing about a compound is it has to also have a fixed proportion of particles. Now here we have only two gray ones and all the other ones are white. So that's not actually going to form a ratio, a particular proportion, which actually makes it a mixture. This actually is an alloy, okay, which is a mixture of either metals or a metal and another element. Okay, so to recap about atoms and ions now, and molecules. A molecule is a group of the same atoms that are joined together. So you can have a molecule of an element, such as H2, which is hydrogen, or you can have a molecule of a compound. An example would be, let me give you an example here. CO2 would be a compound, but it's a molecule because it's more than 2 atoms chemically bonded. This will not be a molecule because it is just 1 atom, helium, a monatomic noble gas. If you have O2, that's a molecule of an element because it's the same type of atom, but there's still 2 atoms chemically bonded. So as soon as you have 2 or more atoms chemically bonded, you have a molecule. If they're the same, it's an element. If they're different, it's a compound. And then the word ion essentially means a charged particle. So like Na plus, Cl minus, OH minus, they'll have to have charges. Now, I will make that clear when we do the topic on ions and ionic bonding. So for now, you don't have to worry about them. Just know that they have charges. That brings everything to a close with one final exercise where you have to join these together. These are the final answers. So element with the definition and the particle diagram. Mixture, molecule, 2 or more atoms chemically joined together. Compound, this one compound, another compound. Remember, this is a molecule too. These should be touching, by the way. So that brings to a close the elements, compounds, and mixtures topic. And in the next lesson, we will be looking at how to separate mixtures. So mixtures can actually be separated because they're not chemically bonded. Compounds are chemically bonded, so we cannot use physical means to separate them. So the separation techniques in the next lesson will be about physically separating mixtures. See you next time.